Good morning. This is very important example on residues, and we have to evaluate this integral where C is a circle. The three parts are given to us. These are the three circles given to us, and we need to find this integral with respect to these circles. So let's move on to the first part. Here the circle mod z equal to 1 is given. So first we have to find the poles of fz, and we have considered our function to be fz equal to z minus 3 divided by this denominator. First we need to find the poles of fz. How to find the poles of fz? For that, just take this denominator to be equal to 0 and get the value of z. So when taking this denominator equal to 0, we get the value of z to be, this is minus 2 plus minus square root of, this is 4 minus 20 divided by 2, and that is equal to minus 2 plus minus, this is minus 16 square root. So that is 4 iota divided by 2, or it is equal to minus 1 plus minus 2 iota. So we are having the value of z to be minus 1 plus 2 iota and minus 1 minus 2 iota. Now we need to check which of these values lying inside the circle mod z equal to 1. So if I draw the circle, the unit circle mod z equal to 1, so I am having this circle, right? This point is what? If I take this point to be in a Cartesian coordinates, if I take z to be x plus iota y, that is equal to minus 1 plus 2 iota. We have taken this point first. What is the real part? It is minus 1 and the imaginary part is 2, right? That is, we are having the point minus 1 2. That means we are having the point this to be as minus 1 2, right? From here. Now if this is the point 1, this is negative 1, this is 1 and this is negative 1, this is the origin. Is this point lies inside the circle? X is negative 1 and y is 2, that means the point lies here, that is outside the circle, right? Similarly the another one, this point, this is what? The real part is minus 1 and the imaginary part is minus 2. This point lies also outside the circle where x is minus 1 and y is minus 2, that is this point lies over here. So both the points lies outside the circle, as both the poles of fz lies outside the circle. Mod z equal to 1. So by Cauchy's residue theorem, this integral is, the given integral will be 0. Because if one of the point lie inside the circle, then we find the residue of fz at that point, right? And then we apply the Cauchy residue theorem for that, and we get the solution, right? But here, as both the points lies outside the circle, we are not going to find any kind of residue, so the given integral is 0. Next, for this circle, we need to check which of these points lies inside this circle. Now how to draw the circle this? What is the center for this circle? The center is z minus, I can write this as iota minus 1. The mod equal to 2, right? I can write this circle as this. So we have this to be the center, that is minus 1 plus iota. So from here we get the real part to be minus 1 and the imaginary part to be 1. So this is the center. So we have this point to be as minus 1 1. Okay. Now to check which of these points lying inside the circle. So here the real part is minus 1 and the imaginary part is 2. So first point is minus 1 2. Is this point lying inside the circle? Minus 1 and 2. Yes, this is the point. So yes, this point lies inside the circle. And what about this point? The real part is minus 1, imaginary part is minus 2. So minus 1 minus 2 is this point. So it is lying outside the circle. So this point does not lying inside the circle. So only this point lies inside the circle. So writing here, only the pole z equal to -1 plus 2 iota lies inside the circle. So now finding the residue at this point. So the residue of fz at z equal to -1 plus 2 iota. Let me consider this as alpha. So the formula is limit z tending to alpha, the point z minus alpha f of z. So this is limit z tending to alpha, z minus alpha, writing fz, that is z minus 3 divided by z square plus 2z plus 5. So when I put this limit z equal to alpha, I got 0 by 0 format. So now by L'Hopital's rule, derivating the numerator, first function derivative of second plus second function derivative of first divided by derivating the denominator. And now putting the value of z equal to alpha over here, we get first term to be 0, second term to be alpha minus 3 divided by 2 alpha plus 2. And now putting back the value of alpha as -1 plus 2 iota over here in place of alpha. So this is -1 plus 2 iota minus 3 divided by 2 alpha, that is -2 plus 4 iota plus 2. So -1 minus 3 is -4 plus 2 iota divided by these two cancelled out, and here I am having 4 iota. Or we can also write this as iota minus 2 divided by 2 iota. So this is the residue of fz. So now by Cauchy's residue theorem, the given integral is equal to 2 pi iota times the residue of fz at z equal to -1 plus 2 iota. So that is equal to 2 pi iota. We have already calculated the residue to be iota minus 2 divided by 2 iota. So 2 cancelled out with this, iota cancelled out with this, and we get pi into iota minus 2 to be the answer for this integral. And now moving on to the next part, that is this one. And what is the center for this circle? If I write this circle to be as mod of z minus -1 minus iota equal to 2, then we have the center to be equal to -1 minus iota. If I write this in Cartesian coordinates, this will be, the real part is -1, the imaginary part is -1. So the center lies at the point -1 minus 1 over here, and is having the radius 2. So moving away 2 units, the circle is like this. Now we are having the function fz to be equal to z minus 3 divided by z square plus 2z plus 5, and it is having the poles z equal to -1 plus 2 iota and -1 minus 2 iota, right? So which of these two poles lies inside the circle? It is having the coordinates -1, 2. It is having the coordinates -1, -2. Let me check this point. This point lies, okay, x is -1, y is 2 over here. So it is outside the circle. So it is not lying inside the circle. And this point -1 and -2, yes. This is -1, this is -2. So this point is lying over here, yes. This lies inside the circle. So among these 2 points, only one pole lies inside the circle. Only the pole z equal to -1 minus 2 iota lies inside the circle, the given circle, So now we have to find the residue at this point. So finding the residue of fz at z equal to minus 1 minus 2 iota, and the formula is, it is limit z tending to, okay, let me name this as beta. So z tending to beta, z minus beta into f of z. So this is equal to limit z tending to beta, it is z minus beta, and what is fz? It is z minus 3 divided by z square plus 2z plus 5. When putting z equal to beta in place of z, it is of the 0 by 0 form. So now we have to apply the L'Hopital's rule. So we have to derivate the numerator with respect to z. So first function derivative of second plus second function derivative of first divided by, derivating the denominator, this is 2z plus 2. Now putting z equal to beta in place of z, we get the first term to be 0 and second term beta minus 3 divided by, in the denominator, 2 beta plus 2. Putting back the value of beta, that is minus 1 minus 2 iota. So this is minus 1 minus 2 iota minus 3 divided by, so this is minus 1 minus 2 iota minus 3 divided by twice of beta, that is minus 2 minus 4 iota plus 2. So these two cancelled out. In the numerator, this is minus 1 minus 3, that is minus 4, minus 2 iota divided by minus 4 iota. Cancelling all the negative sign and also taking 2 common, we get 2 plus iota divided by 2 iota. So this is the residue we have calculated, and now applying the Cauchy's residue theorem to evaluate the given integral. So the given integral over this given circle is equal to 2 pi iota into the residue of fz at z equal to minus 1 minus 2 iota, the point which is lying inside the given circle for the third part. So this is 2 pi iota into, what is the residue? It is 2 plus iota divided by 2 iota. Let's cancel this iota and also 2, and we get this to be pi into 2 plus iota. That is the required solution for the third part. Okay, thank you. Stay blessed.